Let's start with this one, which is this one. So can you, I hope now you can see this picture, which I have just pasted here. So let's start. What is this process? So process is, this is a, as you guys know, that this is a hydrothermal process. So this is, let me rewrite this thing. This is hydrothermal process, and more precisely, it's a wet oxidation process, and more precisely, it's a wet oxidation process because we are using oxygen in this case, right? So I hope you can see this. Oops, I'm trying to explore its features as well. I'm just trying to narrow this down. Okay, so this is the thing which you can see that. So this is Al, and this is oxidation process, right? So let me rub these things, okay? All right, so in this case, what we have municipal solid waste, which is inside this reactor, as I'm dotting this down. So what we get is, because municipal solid waste, that is in solid form, so what we do is we crush that, and mix with liquid water, something like this. We add municipal solid waste, we add some water as well, and we mix them up and make a mixture. Normally it's 2 to 10% mixture. So like if we have 2 grams of municipal solid waste, it's remaining as water, right? So after mixing this thing, so what we do is we put all this thing in this mixture. We put all this mixture in this, and because it's a batch process, so we close this reactor, and then after that we inject oxygen, which is, this is oxygen cylinder, and oxygen goes like this inside, and it's pressurized up to 30 to 50 bar. Okay, now if after it's pressurized and feed is already entered, as we have done so far, feed is already entered. In fact, this is through this thing which goes like this and is filled, right? So and after that, what happens, it's pressurized, and this equipment is equipped with pressure gauges, impeller, valves, sample collectors, thermocouple as well. So once it's pressurized, then what we do is we start heating this material. We heat this up to subcritical conditions of temperature and pressure, which is normally 200 to up till 400 degrees Celsius. And we give a residence time, maybe I think from 30 minutes to anywhere around 2, in fact that's 2 hours. So it's 2 hours, 30 minutes to 2 hours, okay? So this is the whole process which happens, and what happens as a result, the municipal solid waste plus oxygen with pressure and heating this thing becomes product like acetic acid plus carbon dioxide plus water. There might be some other products as well. So this is the actual thing which happens in the whole process. Because this process takes place at a very extreme conditions of temperature and pressure, so that's why sometimes this takes place in the presence of catalyst, just in case to facilitate the reaction process. And during this process, this impeller keeps on running like this, so that it's mixed properly when its reaction is taking place, and constantly outside it's cooled as well, so that temperature of the reactor is kept constant. Then after given residence time, whatever you have selected, let's say you selected 1 hour, so after 1 hour, so what we do is we get this product as sample, right? And then we analyze that sample for acetic acid or product compositions. Okay, so this is the whole process. I hope it's clear. So, but after that, because normally, as we said, there are some gas, carbon dioxide, and water as well, so which is here, so that is released through this gas outlet. So this is, in fact, this is actually the process understanding. So this is the actual process understanding of this thing, right? And this is a batch process. And it takes place at subcritical conditions. Now, important point here is this acetic acid which we produce, this is not pure. Like after this reaction process, what happens is normally we need some separation thing. Like if we have a product, let's say after 1 hour, we got some product here filled with something, right? It contains acetic acid and other products. So this needs a called thing separation, right? So let's say it's acetic acid and other products and other. So this separation actually separates acetic acid and other products. So this is a separation process. So if I highlight few points here, there are different important steps involved in this process. One is collection of municipal solid waste. Second is this reaction, the whole thing, the reaction, the whole thing. The third is this separation, right? And these are three main steps which you need to have a look when you are designing such kind of process. Okay, so this is the whole thing. And if I go further, I hope it's clear. Now if I write few important steps, there are few important steps. One is waste collection. Then it's a reaction, which is wet oxidation, and then product separation. So these are three important steps which you need to have a look when you are designing such concepts. So for deliverable 1, you already have done few tasks, like you have done material balance, you have done report, and other tasks as well. Okay, I don't want to go into the detail. For deliverable 2, you need to complete energy balance, plus Aspen plus simulation plus optimization, what else? Process flow diagram. Remember, this is not a block diagram. In process flow diagram, you use actual drawings. You need to mention conditions. You need to mention equipment and everything. You need to look into that. Plus, you have done the optimization. You need to write the report as well. I think please check other tasks as well. There are some other tasks as well which you need to look to complete for deliverable 2. Now for energy balance, you need to use information which you have done, which you have generated for material balance. So material balance, because energy is dependent on mass balance as well, and please use that information for energy balance. Then Aspen plus, in that case, I think there are two main steps which are more complicated other than other things. These two are more complicated. First, because municipal solid waste that doesn't exist in the component library of Aspen Plus. So that's why you need to generate hypothetical components. Hypothetical components. What are hypothetical components? You give some information like molecular weight and other information, and you hypothetically generate components similar to municipal solid waste, okay? Or you can use some other strategies as well, like for example, if some material or some component behaves exactly similar to municipal solid waste, you can use that as well. But if not, then you need to generate municipal solid waste hypothetically in the component library. Then after that, you need to select a thermodynamic model. Now there are a bunch of thermodynamic models which are available in that simulator. Depending upon the type of components you are using, you need and process conditions which you are using, you need to select an appropriate thermodynamic model. I think you just sometimes you need to have trial and error, because let's say sometimes if Peng-Robinson is recommended, but maybe for your simulation it's not working very well. So sometimes you need to trial and error different thermodynamic models which can best serve your purpose. So after selecting that thermodynamic model, so what you need is you need to build a flow sheet. In flow sheet you have different unit operations, from waste collection, about reaction and product separation. But I feel that the modeling of the reactor would be a little bit complicated, because this might not be handled with CSTR, which is a conventional way, or plug flow reactor. So for this thing, maybe please consider and talk to Dr. Saptashi as well, that so if you can use other reactors such as yield reactors, or you can use Gibbs reactor as well. Please look into the details of this thing as well, if you can use these things, because normally if percentage conversion is given, you yield reactor, and if no information about the process is given, then you can use Gibbs reactor as well. So this is about Aspen Plus, and then using that Aspen simulation, then you can use optimization as well. So optimization, it's just like, it's in simple words, it's you optimize your process by manipulating different parameters. So this is optimization. You can use this simulation for optimization as well. And in other case, you can use some manual optimization, some basic optimization as well. So there's a lot of literature available for optimization of a process. So how to do that, what are the basic optimization things and everything. So please look into that thing as well. Then I think this is plug flow diagram. Plug flow diagram, I think it should be continuation of your block flow diagram which you developed before. So plug process flow diagram should be an updated version of your block diagram which you have built in your deliverable 1. Then you might need to write all the details in your report, and as we discussed, the structure of the report is very much similar what we have talked about before. Then there are, I think, some other tasks as well. Please look into that thing, what is required for deliverable 2. So please look into that and let me know if you have any problem. So this was a kind of like deliverable 3, and in this is a kind of like, please go through this step. First of all, do energy balance, then Aspen Plus, maybe then optimization, and you can use this parallel process flow diagram in parallel and other tasks as well. About this deliverable 2 and Aspen Plus, I want to mention an important point, which is very important. Let me write this. So what is that important point? Important point is, okay, after building your Aspen Plus simulation, now you need its validation, right? This is called model validation. This is very, very important, because what is this model validation? Model validation means that whatever you have done or whatever calculation you have done with your hand by using some formulas, by energy balance, by mass balance, or something like that, your model should give similar results to your calculations, right? This is very important, right? Like, for example, you calculated material balance of, for example, this was your process, okay, and 1 kilogram per hour was coming in, and 1 kilogram per hour was going out. This is your based on calculation, right? Now, when you build this model of similar process, when you build this model, in that case, this should be close to 1 kilogram per hour, and this should be 1 kilogram per, close to 1 kilogram per hour as well. This is called model. So the results by your calculations and results by your model, they should match with each other, right? So this is called model validation. This is called model validation. So if the results of your calculation and results of your model, they are similar, that means your model is correct. But if they are not similar to each other, they are far apart from each other, so that means in that case your model is incorrect and you cannot use that for any of your objectives, including optimization as well. So remember, when you are building this model, you need to check its model validation as well. Okay? Excuse me. I hope this thing is clear so far. So what else is missing? Now this is deliverable 2. Important point which I want to highlight here is report. When you write your report, try to make it as precise as possible, right? It should be precise, should be well structured. Proper reference. Proper referencing, right? So there are different softwares which are available for referencing as well, which I mentioned many times. So you can use EndNote, or you can use Mendeley. For automatically giving these references, right? So remember, the report should be precise, the structure should be well structured, so the first paragraph should be linked with the second paragraph, and second paragraph should be linked with the third paragraph, and then in the end you should give proper reference. Tables should be properly formatted, figures should be properly formatted as well. Remember, always give caption to the tables. Always give caption to figures as well. So don't forget these things. And if you are using some figure which you haven't drawn, always give some reference for that thing. Otherwise, it's called plagiarism. So whenever you are using a picture from some content, some book, some article, or some other internet source, so please always remember to give the reference of that thing. Okay? So this is a brief introduction about thing. One of the important tasks which I can remember is about the three. I think you need process control structure. Process let me rub this first. So that is process control structure. The process control structure is you need to design process control around your process, right? So how we can say that? Like, for example, you have a reactor. For example, this is your reactor, maybe your wet oxidation process. And this is your impeller, okay? Now some reaction is taking place inside like this, okay? Now you need to control the temperature inside, right? So you need to control the temperature inside, right, of this reactor at, let's say, 220 degrees Celsius. Now this tank has a cooling jacket around this, which actually supplies water, cold water, which keeps its temperature constant, right? And that water is supplied by a valve on the other side like this, okay? Let's say that is V1, this is temperature, right? So we want to control this temperature. Now if I rub this again, I can draw this a little bit quiet, okay? Alright, so this thing is like this, and I want to control temperature here. Okay, so how I can control this? If I open this hole and that here water goes out as well, because there should be a vent as well, right? Okay, now if you see this, I want to control this temperature. through this control valve, which is supplying cold water, right, to control the temperature of this reactor, right? So how I can do that? So first of all, I will install a thermocouple here that will measure temperature for me here. So that will tell me, okay, let's say for example temperature is 250 at the moment. So that means this is more than my required temperature. I require 220, but at the moment it's 250. What do you think what will happen? So this will go back. This information will be provided to the controller. That controller will increase the valve opening here, mean more water will go in, cold water, which will reduce the temperature down to 250. And here is the set point. We can provide set point of 220, right? 220 degrees Celsius. Okay. All right. So let me write this again. So 220 degrees Celsius. So by like after some time, let's say because we are supplying more cold water will reduce the temperature down to 200, right? Sorry, 220. So this is how control works. If it's below, let's say for example, in second case, it is 200, I mean too cold, then our set point. So in that case, what will happen? So if we have 200 at the moment, that means it's colder. So what will happen? That information, that temperature would be measured. That information would be provided to the controller. Controller will check what is the set point. So here it's coming 200, right? But it's 220 required. So this information will be given to this valve, which will close this valve so that less water goes from there and water will reduce here, so which will rise the temperature to 220 after some time. So this is called how process control works. Process control works, right? Or process control design. So in one of your tasks, either I think it's D3, I think, or D2, you need to design process control for your process as well. In my opinion, in your case, mainly there would be two main process control loops. One should be around the reactor to control the temperature, and the other one should be around, in fact, other should be around separator to control the concentration. So in fact, around reactor, there can be two process control loops. One is to control the temperature. One is to control the temperature. The other one to control pressure, because pressure is very important. This tank is pressurized, right? This tank is pressurized. So these are the two control loops which you need around the reactor. Around the separator, this is your product and it's producing two products, and let's say this is mixture and this is your acetic acid and this is your other products. So you need to control the concentration of your acetic acid at this case, right? So this is how you design a process control in such processes. Okay, so I hope this was a little bit helpful. And if I go further, what's next? Also, I think one of the tasks was to design individual unit operations. Okay, So now I think you can select your own unit operations, or if you will ask me, I can select that who will do which unit operation. So if we summarize what are the different unit operations which are involved in this, waste collection is not very important. So reactor is one, reactor. Two is separator. Third one may be pumps. Four may be compressor. And fifth may be heat exchangers, because there are different heat exchangers which are involved. Heater or cooler. Right? Heat exchanger. Okay? So these are 5 main unit operations which comes in my mind. So these can be multiple units as well. So reactor and separator are main unit operations, or maybe heat exchanger to some extent is main, you can say that, but there will be some multiple pumps and multiple compressors which will be involved. So based on your own understanding, so you can select who wants to design reactor, who wants to design separator, who wants to design compressors, pumps, and heat exchangers. So, or you can even distribute that 2 people can do reactor, 2 people can do separator, so because they are a bit more complicated, right? So this is the thing which you need to have a look, and you need to individually decide you need to decide who will do which unit operation and all that. Okay, so there are some different materials, reading books, which are available to design each of the reactor, separator, pumps, compressors, and heat exchangers. So please look into those books or materials. There are different strategies which are available for designing such processes. So this is the important thing. So please, I think you guys are different group members. So I think each of you need to design one main unit operation and one small, I think, unit operation. So you can decide by yourself, like 5 people, each of you can select one main unit operation and one small unit operation. It's up to you, or if you will tell me, I can decide for you guys as well. Okay, so what else? So again, coming back to that report writing, so I just want to mention that the report writing is very, very important. So please pay attention when you are following a structure, and you need to, as you know, that you need to follow APA style, but you need to have a proper structure. That structure should be easy to follow. Please always check your spellings, grammar, and everything, so before submitting your report. So that's very, very important as well. Like if you have like 10 mistakes in your report, so the impression looks very bad in that sense. So please pay attention to these things. These are very minor things, but that can be that can add a lot of value in the end. Okay. All right. So this is I think all the things. One more thing which is coming in my mind is another task was you need to have environmental, safety, Hazop, I think, and economics. So these things you need to cover as well. So environmental mean when you will install this process, so how that will affect the environment, like in the terms of like what toxic materials it will release, what toxic gases it will release in the environment, or how it can harm water bodies or other things, right? Safety, when you're installing a process, how safe is that? Is it a safe operation? Is there some toxic chemicals which will be released? Or remember, your process takes place at extreme conditions of temperature and pressure, so that's a big safety concern. So you need to look for different strategies how you can make your process safer. You can add additional layers of safety in each of the process. Then Hazop, this is another study which you need to do as well, that Hazop, which is very common. Then you need to develop an economic study of this process as well. And that is actually, and you know that in engineering, economics is very, very important, right? So like if you invest $1 million, in the end, how much you will save, right? How much you will, how much revenue you will generate. If you are investing 1 million, but you are generating a revenue of $800,000, so that means this process is not economical. And economics, there are two main cost, capital cost, like when you are building this process, capital cost, and operational cost when this process is running. So you need to look for all these things like capital cost, how much cost of this equipment, labor cost, everything when you are constructing a process, right? But when you are running a process, like you are, engineers are running, workers are running, you need raw material, you need electricity, you need all these things. So all these are included in operational cost. So the total cost is you need to combine them together. So if you are investing $1 million, $1 million, sorry, I'm expanding this. So if you are investing $1 million, in the end, your revenue should be much more than $1 million, okay? So that you can save, this process is economical. So that was a kind of like summary for the whole thing. So I just want to tell you, please keep on working like this. Please let me know if you have any problem and we can have a discussion on that thing. So please go through all the materials and tasks, and don't hesitate to ask me any question. I hope this was helpful, and let's go back to your thing. I can go back to this process, and I hope this this lecture was helpful. Please don't hesitate to ask me any question. Just email me or talk to me. I hope everything would be well. So good luck. Have a nice day. Thank you very much.